Hi, today we're going to start our last section in chapter 4, applications of trig functions, and we're going to look at some right triangle trig applications. We're going to look at some information about bearings and headings, and then some simple harmonic motion, which some of you will recognize from your physics classes. But we're going to begin with right triangle trig. And what this says is, from a point on level ground 80 feet from the base of the Eiffel Tower, here's my Eiffel Tower, here's my ground, and hopefully they make a right angle. 80 feet, it says, on the ground from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. That's this angle right here, 85.4. That's the angle that you would have to look up through to see the top of the Eiffel Tower. And we're going to estimate the height of that tower to the nearest foot. So that's a right triangle. We could use our right triangle trig. So we've got opposite and adjacent. That means we're talking about a tangent. The tangent of 85.4 would equal the height of the tower divided by 80. And since we have a variable on the top, we're going to multiply. Our height is going to be 80 times the tangent of 85.4. Grab my calculator, check my mode, I'm in degrees, ready to go. So I'm going to 80 times the tangent of 85.4, and the Eiffel Tower, according to that, is about 994 feet tall, around 994 feet tall. Good. Suppose a tourist is 110 feet from the base of the tower. So now our situation has changed, but the one thing that hasn't changed is the height of the tower. It is still 994 feet. A tourist is 110 feet away, and the question is about finding the angle of elevation. That's that angle to the top of the tower. Still a tangent problem. It's just that it's the tangent of an unknown angle. Is 994 divided by 110. Go to our calculator to get when we need when the variable is in the angle, it's an inverse tangent of 994 divided by 110. And according to that, the angle of elevation is about 83.7 degrees, around 83.7 degrees. Good. So right triangle trig, very important. By definition, the bearing from point O to point P is the acute angle that the ray OP makes with the north-south axis. Okay, let's read that. The bearing from point O to P is the acute angle that OP, the ray, makes with the north-south axis. So that's, it's talking about this angle. The way your book describes this angle is this: north 50 degrees east, and you can see that they're talking first about its relationship with that north-south axis. It's on the north side of that. The angle is 50 degrees headed in the easterly direction. If I were talking about this, I would call that same picture 50 degrees east of north. So I want to tell you, this is what I'm familiar with. This is what our textbook uses. So as we're going to fill in some instructions here, the first thing you have to decide is whether that acute angle is measured from the north or the south side of that north-south axis. Okay? North or south will always be that first letter. Write the measure of the angle, and then determine whether the angle is on the east or west side of that north-south axis. Okay, that's going to be our strategy. I'm going to ask you to come up here now and do this with me. I want you to talk about this angle the way that your textbook would. So it's measured on the north side. We're going to start out with an N here. Then it's the measure of the angle. and then whether that angle's on the east or west side. Well, this one's on the west, so your textbook would call that north 65 degrees west. I would call that 65 degrees west of north. So I hope that you're seeing it from both perspectives. Here's one for you to try. The first thing we have to do is determine whether we're on the north or south, and we're on the south side. We are 70 degrees to the east of that thing. For me, I'd say 70 degrees east of south. Okay, so that's what bearings mean. Now we're going to solve a problem that uses bearings, and this one is just a little camper. All right, you leave the entrance to a system of hiking trails and hike 2.3 miles on a bearing of south 31 degrees west. Then the trail turns 90 degrees clockwise, and you hike 3.5 miles on a bearing of north 59 degrees west. At that time, how far are you to the nearest tenth of a mile from the entrance of the system? You guys, we need a picture, okay? So I'm going to draw myself a north-south axis right here. And according to this thing, I'm going to be on a bearing of south 31 degrees west. So I'm headed this way. That's 31 degrees, and I have walked 2.3 miles in that direction. When all of a sudden I turn 90 degrees clockwise and hike 3.5 miles. I make a 90-degree turn and I hike 3.5 miles along there. And the bearing on this new thing, so this is where the corner was, you guys. I'm going to make a new north-south axis right there. My bearing is north 59 west. So here's my path. That angle is 59 degrees right there. And I've walked 3.5 miles. This is where I am right now. Okay, I think to myself, oh my goodness, how far am I from the system? Well, that's, folks, that's a right triangle problem. From the start of the system, which was right there, I walked 2.3 miles here and 3.5 there. So 2.3 squared plus 3.5 squared equals my journey's length squared, so x squared. Calculator. 2.3 squared plus 3.5 squared is 17.5 square root of 17.54 is 4.18 about, to the nearest tenth, so 4.2. 1754 was the square, about 4.2, so I am around 4.2 miles from the start. And I think to myself, wow, that is a messed up picture. But now it's asking me, what's my bearing to the nearest tenth of a degree from the entrance of the trail system? So now I have to find the bearing here. Yeah, I think I can do that. Well, let's see. My bearing to the nearest tenth of a degree from the entrance to the trail system. So, ladies and gentlemen, I need this angle because that's going to get my bearing angle. And I know part of it is 31, but I don't know this part where I'm putting that dot. So I need to find that dot angle there. And it is a right triangle, so I can find it by using, let's see, the tangent. The tangent of my dot angle is 3.5 over 2.3. And let's see, calculator. I need the angle whose tangent is 3.5 divided by 2.3. And the calculator says that little angle is about 56.7 degrees. That angle is about 56.7 degrees. If I add that to the 31 degrees that I already had up in that corner, I am, okay, 87.7 degrees is the angle measure, but I want the bearing. So I go here and I think, okay, this point is based off the south end of that, so it's south. Then it's the angle that we just found, 87.7 degrees, and we're on the west side of that north-south axis. So south, 87.7 west. Or if you were me, you would say I am now 87.7 degrees west of south. All right, that bearing stuff was pretty new to me. Kind of interesting. A sine. Should be times in there. WT. The motion has amplitude A and period 2 pi over the multiplier, the angle multiplier, which is W in this case. The frequency, which is the number of cycles, of complete cycles, number of complete cycles, in one time unit. Frequency is the number of complete cycles in one time unit. A formula for the frequency is W over 2 pi, which you will notice right away is the reciprocal of the period. If you think about that, that kind of makes sense. The frequency is the number of complete cycles in one time unit, whereas the period is the time required to complete one full cycle, reciprocals of each other. An object is moving in simple harmonic motion described by, and here's our equation, 12 cosine pi force t, where t is measured in seconds and d in centimeters. We want to find the maximum displacement. That is, if you think about something that's in cyclic motion, goes up and down, the total displacement would be the total movement, twice the amplitude. In this case, that would be 2 times, I just lost the equation, 2 times 12, or 24. And those would be centimeters. The frequency is W, which for us is pi fourths, divided by 2 pi. And I'm going to put that over 1, because I want to remind you that dividing one fraction by another, you flip the bottom one and multiply. Pi fourths times 1 over 2 pi. Pi's cancel, and we have 1/8 is our frequency. The time required for one cycle, well, that's the period of the function, right? Time required for one cycle is exactly what period is, and it is the reciprocal of the frequency. So it's the reciprocal of 1/8, or 8 seconds. So the time required for one cycle is the reciprocal of 1/8, or 8 seconds in this case. So, all right, that's the end of our lesson for today. We hope that you'll get out there and do that. You try at your earliest